You know when Spotify just gets you? It builds the perfect playlist from one song you like, or how Amazon seems to read your mind? Well, that's not magic. It's an incredibly powerful idea that is completely reorganizing our digital world. It's called the Semantic ID, and you can think of it as a GPS for, well, everything.
I mean, seriously, think about it. You listen to one obscure indie track and boom, a flawless playlist just appears. You look at one product online and suddenly your feed is full of things you didn't even know you wanted. This isn't just a lucky guess. It's the elegant solution to a massive, mind-bending problem. How do you make sense of billions of items all at once? The answer is a total game changer.
So here's how we're going to break it all down. First, we'll look at what I call the billion item problem. Then we'll dive into the solution, an ID that actually has meaning. After that, we'll peek under the hood to see how these smart addresses are built, check out the incredible real-world results from giants like Amazon and Tencent, and finally, look at the amazing future this tech is unlocking.
All right, let's jump right in with the core challenge here, the billion item problem. See, when you're dealing with catalogs the size of Spotify's or Amazon's, a simple ID number just doesn't cut it anymore, not even close.
The old way of doing things uses what we call an atomic ID. Think of it like a random serial number on a library book. That number tells you absolutely nothing about what's inside the book. But the semantic ID, that's totally different. It's like the Dewey Decimal System for the entire internet. The ID itself tells you the item's address, breaking it down from a broad category, like music, all the way down to something super specific, like grunge.
And that old system is full of problems. First, to give every single item a unique digital fingerprint, or embedding, you end up with these gigantic, insanely expensive data tables. Second, you have the classic cold start problem. A brand new song or product is basically a ghost in the machine. The system has no data on it, so it's invisible. And finally, the old recommendation process is this clunky, multi-stage pipeline where each step has a different goal, which, you guessed it, leads to errors and just okay results.
Okay, so to fix all that, we have to move away from those random, arbitrary labels and start using smart addresses. We need an ID with actual built-in meaning. And this is it, the Semantic ID. It's an identifier made up of a sequence of codes. But the real magic is that this sequence is hierarchical, going from broad to specific. The first code might be a huge category, like shoes. The next one narrows it down, running shoes. The next gets even more specific, trail running shoes. You see, it's a structured, meaningful address in this giant universe of stuff.
Honestly, this is the perfect way to think about it. A GPS coordinate gives you a precise location on Earth, while a semantic ID gives a recommendation engine the precise location of a song, a product, or a video on a vast map of meaning. It stops guessing and starts navigating.
So why is this such a massive game changer? Well, first, your data tables don't have to grow endlessly with every new item. New stuff can get recommended instantly because the system understands its content, not just its click history. It gets rid of that messy pipeline and replaces it with a single, elegant model. And this last one? This is the real kicker. We're shifting from just searching for items to generating the address of the perfect item directly.
Okay, that sounds great in theory, but how does it actually work? How does a song, or a product, or an idea get turned into one of these powerful, structured codes?
This process is called residual quantization. Now, it looks a little complex, but the idea behind it is actually pretty brilliant. First, the system creates that digital fingerprint of an item. Then, it finds the closest general category in the first code book. Let's say that's code number 7. But it's not a perfect match, right? There's always a little bit of info left over. That's the residual. So the system takes that leftover bit and finds the closest match for it in the next, more specific codebook. It just keeps doing this, getting more and more precise with each step until it builds the full semantic address.
So to boil it all down, it's really just a 3-step process. You encode the item into that digital fingerprint. You quantize it layer by layer, creating that sequence of codes. And then you decode it, and that sequence of codes becomes the item's unique, meaningful semantic ID. Simple as that.
Now, the first version of this technique, RQ-VAE, was powerful, but it had this little problem called codebook collapse. Basically, some parts of the semantic map were getting ignored. So industry leaders like Tencent developed an even better method called RQ-K-means+. It cleverly prevents that collapse. And get this, it achieves an incredible 99.36% code usage. That's so important because it means the whole system is running at peak efficiency, understanding all the subtle differences between items.
Okay,
This all sounds amazing in theory, right? But the real question is, does it actually work in the wild? Well, let's take a look at the results from some of the biggest tech companies on the planet. First up, a model called Tiger. It was tested on massive Amazon datasets. We're talking beauty, sports, and toys. And Tiger isn't just a small tweak on an old system. It's a completely new generative model built from the ground up on this Semantic Id framework. It basically learns the entire map of products and then generates recommendations from its understanding.
And the results, they speak for themselves. Compared to the previous best models, Tiger showed huge improvements. Just look at that NDCG score. That's a key metric for how good the recommendations are. Tiger delivered a more than 12% improvement. Let me tell you, in this field, that is a massive leap forward.
All right, if you thought the Amazon case was cool, check this out. Tencent's GPR model. This isn't some research project. This is a fully deployed system powering their enormous Weixin Channels advertising platform. And here's the crazy part. It didn't just improve the old system, it replaced the entire thing.
The performance gains here are just staggering. In predicting what users would do, the old baseline hit around 19%. The full GPR model, over 27%. That is a 43.9% improvement. This is just definitive proof of how effective this unified, generative approach is in a super complex, live environment with millions and millions of users.
But these incredible performance gains, they're really just the beginning. This new way of thinking unlocks entirely new capabilities that just weren't even possible before.
We already know it solves the cold start problem, but it also gives us something called tunable diversity. The system can recommend things from a broad category, like just music, rock, to help you discover something new. Or it can use the full super-specific code to give you exactly what you're looking for. And just imagine integrating this with AI like ChatGPT. You could just say, hey, find me a song that sounds like early 90s grunge, but with a modern synth vibe, and it would know exactly what address to generate.
So, if there's one thing to take away, it's this. We are making a fundamental shift from retrieving items to generating them. The model doesn't need a separate index to search through anymore. Its own memory is the index. It has learned the entire map of content, and it can just create the address for any location on that map on the fly.
Which leaves us with one final fascinating question. If every single item, every song, every product, and every idea has a meaningful, navigable address on a universal map, what are we going to build next? The possibilities are just mind-boggling.